Hello everyone. I have something a little different for today. This video marks the beginning of a series that will run for an unknown length of time where I cover different topics of science depending on whatever topic happens to be of interest to me. I will try to keep math and theoretical properties simple so they are easier to understand. My goal after every video like this is to have someone walk away with a better understanding of the topic being presented. If you did not learn anything from a video like this, then feel free to dislike and drive to my house and take a dump on my front porch. Light. It's the radiation that allows us to perceive our world in all its beautiful splendor. The light we can perceive is just a small fraction of possible wavelengths, spanning from high-energy gamma rays to low-energy radio waves. The particle that makes up light is called the photon, and it's the interaction between photons and the objects in existence that allows us to perceive the universe via visible light. Unfortunately, this also means that you have to acknowledge the existence of that one cousin in a family gathering that you wish would just go away. Most objects have unique absorption and reflection properties that define its color. Specifically, every color that is not absorbed by the object is instead reflected back, which then enter our eyes and allow our brains to perceive its color. An object that absorbs all light appears black, and an object that doesn't absorb any light can appear as white, transparent, or many different styles based on the type of object it is interacting with. With the basics out of the way, let's dive a bit deeper into light's properties. As everyone knows, the speed at which light travels through a vacuum is the fastest speed anything in the universe can travel at approximately 300 million meters per second. To put that into perspective, it takes light exactly 1 second to circle the Earth at the equator over 7.5 times. Similar to the speed at which rednecks race to the gas station when they see a 2-for-1 special on cigarettes, the speed of light is inconceivably fast. So much so that we use the distance the light travels in certain lengths of time to measure the massive distances in our universe, the most popular of which is the light year, equating to about 9.7 trillion kilometers. Building on earlier in the video, when we discussed light's interactions with objects, light must travel a certain distance before we can perceive it, meaning every single thing you see is technically the object as it was a fraction of time in the past, depending on the distance between you and the object being observed. For example, if you see a frog 1 meter away from you, you are seeing the frog as it appeared 3.3 nanoseconds ago. On the other side, the distance between the Milky Way and Andromeda galaxies is a little less than 2.5 million light-years, meaning you are looking at Andromeda as it appeared 2.5 million years ago. This property defines the border of the observable universe, as the universe hasn't existed long enough for any light past this horizon to reach the Earth. Now let's explore the more complicated stuff. It is theorized that photons have zero mass, meaning they do not require energy to accelerate, move, or even change direction. This presents a problem, however, particularly to Isaac Newton and his law of gravity. This states that objects with mass will attract each other by some force depending on the masses of the objects and the radius that separates them. As we know, the mass of a photon is zero, so gravity shouldn't affect light, right? Much like when your significant other asks, "Do I look fat in these jeans?" The answer is a bit complicated. Scientists have observed light bending around objects in space, contrary to the law of gravity, meaning gravity affects light somehow even though it has zero mass. Scientists were puzzled by this phenomena. Then, along came Albert Einstein and his theory of general relativity in the late 1900s and early 1910s, which completely revolutionized how we interpret these phenomena. General relativity states that space-time can be distorted by objects with significant masses like stars or black holes, and this distortion forces light to bend around these objects. This theory is also presented with two properties of energy and mass that give light a much more important role in our universe. Energy-mass equivalence, Einstein's most famous equation, shows that energy and mass can be converted between one another, and relativistic momentum, which show that momentum increases exponentially the closer an object with mass approaches the speed of light. Let's try to accelerate an object with mass to the speed of light and see what happens. Energy is required to do work on an object to accelerate it to a faster velocity. According to mass-energy equivalence, increasing the energy of an object proportionately increases the object's mass, as the speed of light is constant. This requires more and more energy to accelerate an object that is continuously increasing in mass, eventually resulting in an asymptote near the speed of light, where an infinite amount of energy is required to accelerate an object of infinite mass. This explains why huge people need motorized scooters to move, and why photons, and only photons, can travel at the universal speed limit. This concludes the video about the properties of light. I did not cover every topic about light, as that would make this video hours long. If you enjoyed the video, why not leaving a like or subscribing? I play games in addition to making videos like these, but if that isn't your fancy, then that's fine as well. Even if you don't subscribe or like, I appreciate you watching the video. Goodbye for now, until the next one.